Today I'm going to take the topic on mobile IP. Mobile IP is a internet protocol which is working in wireless LAN stack. Right? So before going to mobile IP, I'm going to take about a TCP/IP reference model. In TCP/IP reference model, TCP/IP reference model is called as 5-layer model in networks. So there are 5 layers: physical layer, data link layer, network layer, transport layer, and application layer. Right? So where this mobile IP, what is the evolution of mobile IP? Mobile IP evolves from network layer. So network layer, we know that IP is a very important protocol. IP is internet protocol. So whenever we send the data is transmitted to the receiver side using this internet protocol. There are 2 versions in this internet protocol, IPv4 and IPv6. There are 2 versions. So without using IP protocol, we cannot transmit the data, right? So by the use of only internet protocol, we can transfer the data. So what is the purpose of mobile IP? This internet protocol is specifically designed for wired networks. So suppose we are transmitting the data in the wireless medium. What is the protocol? That is a use of mobile IP. So along with IP, mobile IP is also used when we transmit the data through the wireless medium, right? So this is the evolution of mobile IP. In mobile IP also there are 2 versions, mobile IPv4 and mobile IPv6. And we can use IPv4 addresses and IPv6 addresses like IP in mobile IP. Right. So this is the evolution of mobile IP. So using the mobile IP, we can transmit the data from sender to receiver in the wireless medium. So this is a slide about mobile IP. Mobile IP is a internet protocol which is working at network layer to transmit the data from sender to receiver in the wireless medium. Right. So what is the speciality of mobile IP? When compared to internet protocol, mobile IP has specific characteristics. Right. So this is all about slides of mobile IP. Data transfer, encapsulation, security, and IPv6. Right. So we are going to see what is mobile IP. So motivation of mobile IP is, in wireless medium we know that all the mobile nodes are either fixed or random. Right. So think about a random topology. In random topology, the mobile nodes are moving very frequently. So we are transmitting the data, but the data cannot be received by the receiver. The reason is mobility, right? When the nodes are moving from one position to another position, we cannot transmit the data, we cannot receive the data, right? So we cannot transmit and receive the data. So by the use of mobile IP only, we are going to transmit the data. So what is the use of mobile IP? How mobile IP transmits the data when mobile nodes are moving very frequently? That is a question, right? So this is the specific characteristics of mobile IP. So based on IP destination address, destination IP address, we are going to transmit the data through internet protocol. So that is basic characteristics of internet protocol. How mobile IP transmits the data when mobile nodes are moving very frequently? That is a question. So mobile IP also uses IP destination address and network prefix, that is network address, to transmit the data to the receiver, right? So this about when the mobile nodes are moving very frequently, how mobile IP transmits the data. So these are the requirements of mobile IP. Transparency is invisible to the users. So we are thinking about, let us take the example, there are 10 nodes. The first node transmits data to the 10th node, but the first node should not know about the presence of 10th node, only it knows the IP address. So first node will use a 10th node IP address to transmit the data, but one need not know about the presence of where the 10th node presents, right? By using the IP destination address only, that is 10th node address only, first node will send the data, right? So that is called as transparency. Transparency is invisible to the users. So any user need not know about where the particular destination mobile node presents. Second one is compatibility. That is, mobile IP is compatible to all the protocols and its above layer and below layer. Security, mobile IP uses authentication techniques like HMAC, SHA1, MD5, like that. And efficiency and scalability. Scalability is mobile IP will work when mobile nodes are increasing. That is called as scalability. Then these are the terminologies used in mobile IP. Mobile node, that is called as MN, and home agent, that is another entity, and foreign agent, and care of address, and correspondent node. So among these 5 terminologies, care of address is a very important thing, because already I have said that by using the IP destination address only, we are going to transmit the data through mobile IP. So there are 2 types of care of addresses are there: foreign agent care of address, co-located care of address. So what is the use of mobile node? Mobile node is, we are the users, we are the mobile users, so we are called as mobile node. We are transmitting the data to the receiver side. What is home agent? When the mobile node enters into the network at very first time, home agent will store the IP destination IP address of that particular mobile node in the database. So what is the purpose of home agent is, home agent will store the details about mobile node in their database. So what is the use of foreign agent? When the mobile node are moving from one place to another place, so in that new place there is an agent, that agent is called as foreign agent. So when the mobile node are transmitting the data to the home agent will forward the data to the foreign agent through the use of by the use of care of address, and it will be sent to the correspondent node. So correspondent node is a destination node, care of address IP address, foreign agent is a new location home agent is a previous location home agent, and mobile node is a mobile users. So this is all about example network. Here the mobile node presents in this home network. In the home network, this is a router. This router is called as home agent, and it transmits the data to the home agent, and the home agent will forward the data through the internet, right? Suppose the correspondent node, that is mobile node, will transmit the data to the correspondent node. Suppose the correspondent node presents in the home network only, then home agent will forward the data within this network. Suppose the correspondent node has already moved to the new place, what will happen? The mobile node will transfer the data to the home agent, and the home agent will directly communicate with the foreign agent, and the foreign agent will identify where the correspondent node presents by the use of care of address. So there are 2 types of care of address: co-located care of address and foreign agent care of address. When the foreign agent assigns IP address to the correspondent node, that address is called as foreign agent address, that is FACOA. And another address is when the mobile node, correspondent node, present in the home network and move to the new place. After moving to the new place, suppose the correspondent node will get the IP address dynamically from the environment by using the DHCP protocol, dynamic host configuration in the Linux environment. Correspondent node will get the care of address dynamically by its own. That address is called as co-located care of address. When the foreign agent assigns IP address to the correspondent node, that address is called as FACOA, that is foreign agent care of address. So the home agent will transfer the data, will forward the data to the foreign agent by the use of care of address. By using the care of address, foreign agent will identify where the correspondent node presents. After finding where the correspondent node presents, it will forward the foreign agent will forward the data to the correspondent node. So this is what happening in mobile IP. So these are the 3 types of messages transmitted by the use of mobile IP. First is a home network, is a home agent, right? The home agent may be a mobile node, or switch, or router, or any networking device. So mobile node transmits the data to the home agent. Home agent will identify where the correspondent node presents. Suppose the correspondent node is not present in the home network, it will find the foreign agent where the mobile node, where the correspondent node has already moved to the new place. That message is correspondent node will identify, that is correspondent node will send the data. Mobile node, we can take it as a correspondent node, say mobile node. Mobile node will transmit the data to the home network, and home network will transmit the data to the foreign agent, and foreign agent will identify where the mobile node presents. So it will forward the data to the mobile node. So these are the three types of messages. First, correspondent node to home agent, and home agent to foreign agent, and foreign agent to mobile node. So these are the points. Sender sends IP address of MN, that is IP address of this destination, and HA intercepts packets by using the proxy ARP. So by using the proxy ARP, home network, home agent will identify the foreign agent, and home agent tunnels packet to COA, here FA by encapsulation, and FA forwards the packet to the mobile node. So this is what happening in mobile IP. So this is the first point, that is suppose the correspondent node knows about the presence of where the mobile node presents, it will directly communicate with the mobile node. Otherwise, previous one, it will send the data to home agent, and the home agent will forward the data to the foreign agent, and foreign agent will forward the data to the mobile node. Where the correspondent knows the presence of where the mobile node presents, it will use the care of address of the particular mobile node directly, and it will directly communicate with the mobile node. So same architecture is an overview of mobile IP. The home network, here the home agent. So the home, that is data is transmitted from home network to home agent, and the home agent will communicate with the foreign agent by using the COA, care of address. That is, care of address is the IP address, either IP4 or IP6, and the foreign agent will forward the data to the mobile node. So here the mobile node presented in the foreign network. So what are the types of messages? CN to router, router to home agent to foreign agent through internet, public internet, and the foreign agent will forward the packet to the mobile node. So these are the messages transmitted from CN to mobile node, or mobile node to CN, anything. And there are specific functions of mobile IP: agent advertisement, registration, and advertisement. So what are these type of messages? When the correspondent node enters into the network, wireless network, at very first time, the correspondent node will store this IP address in the home agent. Likewise, when the home agent, I have already said, home agent may be a mobile node or any networking device like switch or router. When the home agent will enter into the network very first time, it will also send the advertisement messages, agent advertisement, that is called as agent advertisement. When home agent or foreign agent enters into the network very first time, the home agent and foreign agent will send the advertisement messages. Then only the mobile nodes will know about their presence. Home agent and foreign agent periodically send advertisement messages into their physical subnets, right? So by using the IP address of their own, the agents will send the advertisement messages, so that other mobile nodes, the correspondent node and that mobile node, will store their information in their database. And registration, after sending the details, after sending the advertisement messages, it will register its details in their database and with their neighbor nodes, that is mobile node or correspondent node, right? MN signals COA to the HA via the FA, and the HA acknowledges via FA to the mobile node, right? So this is what happened in the previous one. When the mobile node, first the mobile node presents the home network, after moving to the foreign network, it will send the COA to the foreign agent. Foreign agent will store the COA of mobile node. Then only when the home network communicate with the FA will know about the presence of MN, right? So home network will ask the foreign agent where that particular destination mobile node presents. By using the care of address, the foreign agent will search its database where that particular mobile node presents, right? By using the care of address, it will identify that MN present in my network, right? then it will send the details to the home agent, and the home agent will forward the details to the correspondent node. After that, in future, the correspondent node wants to communicate with that particular mobile node, it will directly communicate with the particular mobile node by using the care of addresses. So this is a registration. When the mobile node or any, this registration is for mobile node or correspondent node or home agent and foreign agent. So this is an example when the mobile node enters into the network at very first time. So after entering into the network very first time, the mobile node will send the registration request to the foreign agent. So this is an example given for mobile node has already moved to the foreign network. What will happen when the mobile node has already moved to the foreign network? So this is what happening in when the mobile node after moving to the foreign network, it will send the registration request to the foreign agent. When the foreign agent will accept the data, will accept the details, it will send the registration request to the home agent, and the home agent will send the reply, and after getting the permission of home agent, it will store the details of that particular mobile node in their database. Right. So when the mobile node enters into the home network, at the time also the mobile node will send the registration request. This is for suppose the correspondent node or mobile node enters into the home network very first time, mobile node or correspondent node will send the registration request to the home agent. So home agent, after getting the details of that particular CN or MN, the HA will store the details about that particular CN or MN. It is a second type. So these are the two types of messages when the mobile node register its presence to the home agent or foreign agent. Right. Where if mobile node has already moved to the foreign network, it will send the request to the foreign agent. When the mobile node enters into the home network at very first time, it will send the registration request to a home agent. So these are the we know that by using the IP protocol we can send the data, right? So this is first messages. These are messages we have already seen in the computer networks, normal wireline networks. This is the original data that will be sent from application layer to transport layer to network layer to data link layer to physical layer, and it will be sent to the receiving side. We know that. How this data is coming from application layer to transport layer. When the data comes to application layer very first time from the end user, application layer will add the application header along with the data, and the whole data is treated as the header, and the application header and the data is treated as whole data, and the whole data will be coming to transport layer. A transport layer along with this encapsulated data, transport header is added, and the transport data will be treated as a whole data, and it will be sent to the network layer. How the network layer will add the headers? In the network layer, I already said internet protocol is a very important protocol to transmit the data from sender to receiver. So when the data comes to network layer, it will add the IP header. It will add the IP header, because IP is a protocol which is working at network layer. But without using IP protocol, we cannot transmit the data to the receiver side. So original IP header is added. So the header and data is treated as a new data. This new data will be added along with new IP header, right? So this new IP header, what is the new IP header? I have already said IP is a important protocol for transmitting the data to the receiver side in the wireline networks. So what is a protocol used for sending the data to the receiving side in the wireless medium? In the wireless medium, we can use a mobile IP. We cannot use a normal IPv4 or IPv6 to transmit the data. So we go for mobile IP, specific protocol for wireless networks. So this new IP header is mobile IP header. Along with this mobile IP header, new IP header, there is original IP header is added, and original data, inner header, and this new IP header, there is mobile IP6 header or IP4 header. So these are the encapsulation messages. There are three types of encapsulation: GRE, and minimal encapsulation. So when compared to other encapsulations, GRE encapsulation is a very important generic routing encapsulation. Encapsulation is hiding the data with IP header. Encapsulation is like we have studied in the object oriented programming. Encapsulation is hiding the data along with some more information, so that we can say that encapsulation is gives security to the data, right? Because we are adding the data, adding the IP header along with the data. So when we add the headers along with the data, and the receivers, sometimes attackers or intruders, cannot find the data clearly. So these are about generic routing encapsulation. The message types in generic routing encapsulation, there are many fields. So how the GRE header is added. So before previous slide, we have seen that original data is added with original IP header, and it will be treated as a new data. In new data, GRE header is added. This is an encapsulation header before adding the outer header. GRE header is added, and the whole the GRE header plus original data is treated as new data. This new data is added with a new header. This new header is called as mobile IPv4 header. So before that, GRE header is, we have we can match this type of generic routing encapsulation with IPsec, IP security protocol. In IP security protocol also, there are two types of tunneling. In the tunneling also, generic routing encapsulation is used. This is a very important slide, the change of foreign agent. So I will say the example by using the same architecture. When this is an example, when the mobile node has already moved to the new place. So here the first mobile node presented in the particular home network. After some time, the mobile nodes are moving to the foreign agent. After moving the foreign agent, mobile node will store its details in the foreign agent by using the after getting the care of address dynamically, or after getting the IP address from the foreign agent, right? So here the mobile node has already moved to a foreign agent. After some time, the mobile node wants to move to another foreign agent. What will happen? That is a question, right? Because at very first time, mobile node presents in the home network. After some time, mobile node has already moved to the new place, so there is new foreign agent. After some time, it will find another location to move. So when at the time the foreign agent will change, right? So this is what I am going to say about change of foreign agent. When the mobile node has already moved to a new place, new foreign agent, after some time the same mobile node wants to change the foreign agent once again. What will happen? The correspondent node, after moving to the new location, how the correspondent node will identify where that particular mobile node present at this particular time. Correspondent node will send the data to the home agent, and home agent will suppose home agent has already having the information about foreign agent, it will forward the data to the foreign agent old foreign agent. Suppose the old foreign agent will search its database where that particular mobile node presents. So it will search the database. So at the time, the old foreign agent will identify that the mobile node has already moved to a new foreign agent. So after getting the data, it will forward the data to the mobile node by using the care of address of MN, right? After moving to the FA new, mobile node will store the foreign that is care of address to the FA new, and FA new will store the care of address to the FA old. That is what I have already said in this registration. MN will send the registration request to the foreign agent. Foreign agent will assign IP address to the mobile node, that is called as care of address. After assigning the care of address to the mobile node, it will send the registration request to the home agent. So in this registration request, the care of address of mobile node will be sent to the home agent. So the home agent will store the care of address of mobile node, of this particular time will be stored in the home agent. Then only when the correspondent node wants to communicate with this mobile node, home agent will send forward the data to the particular mobile node directly. So this is what happening in FA old will know about care of address of MN by using the FA new already. So it will directly communicate with the MN. And after getting the data, home agent will update the correspondent node. Suppose correspondent node will not know about the care of address of particular mobile node at this particular time. So it will update the correspondent node so that the correspondent node will directly communicate with the mobile node in future. So after getting the details of that particular care of address, it will send the acknowledgement to the home agent. So at this with these three messages, we know that correspondent node knows about address of FA old. Address of FA old. In future, the second one, this is the first phase. Second phase is when the correspondent node once again wants to communicate with the mobile node. So now it knows the address of FA old, so it will directly communicate with the FA old, and the FA old directly communicate with MN. Right. So this is the second phase. After sending that is MN changes location from FA new to FA old or FA old to FA new, it will send the registration. So it will send the registration and it will update the FA old. FA new will update the FA old. For getting the details, it will send the acknowledgement to the FA old. So what will happen? Once again, the correspondent node wants to communicate with, wants to send the data to the mobile node. It will send the data to the FA old. Then FA old will send the data to the FA new, because now the FA old will know about FA new, and it will forward the data to the mobile node. So after finding the FA old will update the correspondent node. Suppose the MN changes location very frequently, there is a warning messages. So after getting the warning message, the correspondent node knows about there is a mobile node wants to change the location very frequently. So it will ask the home agent, so what is the current care of address of the mobile node? So home agent will update and it will send the acknowledgement. After that, the correspondent node knows about FA new and directly it will communicate with the FA new. Then it will communicate, it will be forwarded to the mobile node. So this is what happening in mobile IP. By using use of mobile IP, we can transmit the data from sender to receiver. I have already said by the use of internet protocol, we can transmit data, but in wireless medium, how the data will be transmitted? By the use of mobile IP. In mobile IP is specific protocol to transmit the data from sender to receiver when the mobile nodes are moving very frequently, right? So this is a total type of that is types of messages will be transmitted to the from correspondent node to mobile node. So this is a very specific diagram, very important diagram for mobile IP. There is another important concept in mobile IP, tunneling. Tunneling is we know that tunneling is used in virtual private networks. In virtual private network, we can transmit the data from one end to another end in the private tunnels. That is, when we are sending the data through the tunnels, we cannot, the intruders cannot get the data, because by using the tunneling, we can give the security. Tunneling means transmitting the data with security from sender to receiver. So this is what tunneling is a very important concept used in mobile IP, like IPsec. I have already said IP security and VPNs. Tunneling is transmitting the data from one end to another end with security. So here the correspondent node wants to communicate with the mobile node. It will tunnel the data to the home agent, and the home agent will add the headers and the tunnels, that is tunnels to the foreign agent, and foreign agent will forward the data to the mobile node. So what this is a function of tunneling. Tunneling is from correspondent node to mobile node. When after getting the data, mobile node wants to acknowledge to the correspondent node. That is called as reverse tunneling. So the mobile node will send the acknowledgement to the foreign agent, and foreign agent will send the acknowledgement to home agent, and the home agent will send the acknowledgement to correspondent node. So at the time the correspondent node will know the presence of mobile node and the mobile node has already received the data. That is the concept of reverse tunneling and reverse tunneling. Reverse tunneling is also important concept in mobile IP. Mobile IP with reverse tunneling. These are points I have already said. So the tunneling in the tunnels we are using the firewalls. That is when the correspondent node sends data, there is a firewall. The firewall will add the security features to the data and it will be sent to this router. Here the router is called as home agent, and home agent will add in the home agent also there is a firewall. So it will add the more security features along with the data and it will be sent to the foreign agent, and foreign agent will add another security features, firewall features, and it will be sent to the mobile node. So this is what happening in when the data is transmitted through many intermediate nodes. We are transmitting the data to the receiver side, but we do not know the presence of intermediate nodes. So all the intermediate nodes are adding the security features like firewall features along with the data. So tunneling gives, reverse tunneling and tunneling gives more security. That is the use of firewall, right? And there are two versions I already said: mobile IP4 and IPv6. Mobile IPv4 and IPv6. We know that IPv4 uses 32 bit address and IPv6 uses 128 bit addresses. So same 32 bit or 128 bit address will be used in mobile IP also. That is, these are points I already said. Along with this IPv4 and IPv6, security features is integrated. That is mainly the authentication of registration is included. Authentication is verifying the sender. Right? We are, suppose I am going to transfer the data. I am the sender. So I will add my security features along with the data. So when the receiver receives the data, he knows the presence of me, right? So I am the only authorized sender. I have already sent the data. So by using the details, by clearing the details of me, the receiver will accept the data. And handover is a very important another topic in mobile IP. Handover means mobile node first present in the home network. After moving to a new location, so that is handover is roaming. Handover we can take as a roaming. Roaming is that is moving. Roaming means we are having cell phones. So we are the users, we are moving along with ourselves. The cell phones are also moving. That is called as roaming. So the handover is called as process of moving from one location to another location. There is displacement of mobile nodes. That is called as handover. In handover, in wireless environments, there are two types of handovers: soft handover and hard handover. In soft handover and hard handover, there are many sub-classifications also. So that is not very important topic to in-depth topic in this mobile IP, but handover is here the soft handover is used, because after moving to the new location, the MN will get the IP address, that is care of address, by itself or from foreign agent. That is called as soft handover. So soft handover, that is without packet loss between two subnets, is supported by using the care of address. That is the use of care of address. And problems with mobile IP, security features. So mobile IP, when compared to other other protocols, mobile IP has security features, but it is not much important features, because only we are providing authentication. In authentication, along with authentication, confidentiality should be provided so that the data will be reached very safely to the receiver side. So the firewalls we are using everywhere. And quality of service. How this quality of service is how the reliable, how the mobile IP is reliable. That is what quality of service. In quality of service, we know that there are many parameters, and security. So mainly these are the problems with the mobile IP. But mobile IPv6 has more security features when compared to mobile IPv4, because authentication is provided by using the SHA1 or MD5, but mobile IP6 will use more security features when compared to SHA1 and MD5, SHA512, SHA3, 4, 5 will be used by the mobile IPv6. So these are the security requirements in mobile IP, but mobile IP4 will use authentication techniques. When we say about confidentiality and authentication, automatically the integrity of data is provided, because integrity is a process of verifying the data whether it is reached the receiver without any errors. That is called as integrity. When we are providing authentication and confidentiality, so either of these technique will provide integrity, but when we combine the two techniques, authentication and confidentiality, we can provide the integrity. That is a concept. And another technique is non-repudiation. Repudiation is denial of service. When we undeny the services, that is called as non-repudiation. Sender cannot deny sending of data. That is, repudiation is denial of service. When I am sending the data, after some time I can deny that I have not sent this data. That is called as repudiation, denial of service. So denial of service can be provided in two forms: denial of service by sender, denial of service by receiver. When we undeny the service, that is, I have already sent the data. So when I accept I have sent the data, that is called as non-repudiation. Then traffic analysis. Traffic analysis is a very crucial type of attack in wireless media, because we are sending the data. When the data is stolen by somebody, we know that the data is stolen by somebody, but the traffic analysis is very crucial type of attack in wireless. For example, there are two nodes, A and B. So A sends the data to the B will accept the data, but when the intruder C is already presented in the particular network, A will not know about the presence of C, B also will not know about the presence of C. What will happen? When we transmit the data in the communication channel, C will intercept the data and it will copy the data. That is traffic. It will analyze the data. It will analyze the traffic. What are the types of messages that is data transmitted from A to B. So suppose A transmits 10 messages to the B. So all the 10 messages are read by C. That is called as traffic analysis. Traffic analysis is not altering the data, it's not modifying the data, only it copies the data and analyzes the data. So this is a crucial type of attack. This attack will not know to the original sender and receivers. And the replay protection, when we provide authentication, automatically the replay protection will be provided, because the replay protection provides details about the sender, so that I have said authentication. When the authentication is provided, automatically replay protection will be provided. So these are the security requirements in mobile IP, but mobile IP4 will provide authentication techniques. Like authentication is provided using SHA1 or MD5. We can develop this mobile IP4, IPv6 by using the more security features like SHA 512, SHA 3.2 or something else. So these are the IP security architecture. I have already said in the previous topics, tunneling and when we add the headers. So here the IP security architecture, why they are giving IP security architecture along in this mobile IP. Mobile IP automatically provides IP security features, like the TCP data is provided with authentication header, and authentication header is that the whole data will be treated as a new data, and this new data is added along with IP header, and the IP header will be treated as the whole data, and mobile IP header is added, right? So when we transmit the data in the wireless medium, when the transport layer sends the data to the network layer, what will happen is, in network layer automatically internet protocol is working, so IP header is added, along with IP header mobile IP header is also added, so that the security is provided more. That is a concept of this mobile IP. So this is all about how the data is transmitted in the wireless medium from sender to receiver with security. Mobile IP is a very important protocol which is working along with IP, not without using the IP. It is working along with IP, so that the IP header is added. After adding the IP header, outer header is added. That outer header is called as mobile IP4 header or mobile IP6 header. That is a use of IPsec, right? This is a concept of IPsec also. I have already said tunneling. Tunneling will be used. There are two types of protocols will be used in IPsec. There are transport protocols and tunnel protocols. It's all about mobile IP.